Thank you very much, Steve. I hope everyone can hear me. Yes?
Yes.
Okay, good. So thank you for inviting us. Yes, as you said, Steve, we're going to try to cover this topic of a view over the fence, which insinuates that there's a disconnect between the automotive world and the roads and transport world, which going forward, we're all going to have to address. So just to give a little bit more information about ourselves, our evening and weekend job is representing ASIN. ASIN is part of the TechWorks trade body, and ASIN itself is representing the automotive electronics companies in the UK. Steve, as you said, my background is the last few years working in progressively higher levels of automation in new automotive products, and before that, many years in electric vehicle technology. Jed, do you want to touch on yourself?
Going back to the theme of the long-term plans for this, I'm so old I'm in black and white, but yeah, I have spent almost my entire career in the automotive sector working on cars, and in my presentation section I'm going to try and remember to refer to them as vehicles rather than cars, but yeah, I've spent that whole time working on making the vehicles compatible with the rest of the world across all the various diverse standards, and this is just another iteration of that.
Thanks, Jed. So if we kind of start off with a basic of where we're coming from to all get on the same page before we think about where we're going. The automotive worldview is traditionally that we sell vehicles, and the touch points between the customer and the industry are really sort of on an annual basis. You'll as a vehicle owner, have to go through a servicing, and then typically a dealer will try to sell you an upgrade on your product every 2 or 3 years as a kind of sales pitch. And on an unscheduled basis, there are, of course, occasional issues with products, and they can be severe enough that they may need to have a recall. Now, that comes about usually as a result of the data which is gathered by the OEM during the servicing. It goes from the dealer back to the OEM, and a kind of quality control process looks at that data and thinks about potential changes that would need to be made in product, and if severe, then a recall. So the move now is to recognize that why wait until the data arrives at the dealer during servicing? Why not get started on analyzing that data as soon as possible? And so one of the big moves in automotive development has been in progressive diagnostics, and then extracting that information from the vehicle as we move along. And that data can then be processed back at the OEM from a quality control point of view. And yes, if the data insinuates that we need to have a recall, then that's the case. But quite often there are opportunities to make updates to the vehicle in the software. And so there's a connectivity perspective back to the vehicle to make a software update which might remedy or at least mitigate the issues that are found on the vehicle. There's another aspect in terms of connection, and that is the data link part of the eCall program, which many of you will come across. That's alerting to the emergency services from the vehicle. So we can already see some level of connectivity coming in to products as we see them coming now. Now, what's the customer's perspective? They're not aware so much of the diagnostics elements or the software over the air, and hopefully not having to activate eCall, but they will have some awareness of it. What the customer predominantly we see focuses now on is their expectation for seamless information, seamless infotainment, seamless connectivity around the vehicle interface, similar to the mobile connected devices that customers all have. Now, that really brings in a sort of dilemma for the automotive industry. Does the automotive industry develop clusters and infotainment systems to be bespoke, or do they follow a linkage with the mobile devices that customers have in car, either using MirrorLink, or MirrorLink seems to be sort of, not so common now, but Android Auto or Apple CarPlay as options. And you can see there's really a question here. The development cycle for automotive companies is of the order of 3 years, 2.5, 3.5 years, whereas mobile connected devices, the development cycle is more like 1 year. So in this case, there's really a choice here for an OEM whether to go more predominantly in the connected to the device a path, or connected directly to the infrastructure through the vehicle. Now, things are moving forward a bit because, as Steve, as you touched on, we're now bringing into play electric vehicles, and as well as the traditional touch points that we touched on, so the diagnostics piece and the SOTA piece, we're now bringing in subscriptions to charging networks, and there are many charging networks. I mean, something of the order of 20 charging networks in the UK. So the subscriptions could potentially be multiple. And when we're thinking about the connectivity, the connection between the vehicle and the charging network, there's quite some information potential here. The information which is of help is the journey plan the vehicle is likely to do, the range that the battery will allow in the vehicle at that point, the location of the vehicle and its journey progress as it's moving along, and then in return some information about availability of chargers around the charging network, and the possibility to book or reserve a spot on a charger along the journey. And this is, for the OEM point of view, this is also a challenge, because some of the OEMs, for example, Porsche and Tesla, which are shown here, they're already looking at proprietary charger networks, whereas others are partnering up with one or more of the charging networks already being constructed. And then again, on an unscheduled touch point, we have the risk of recovery should the range prediction actually turn out not to be as accurate as was predicted. So where does that kind of take us next? The other aspect is something we've been involved in heavily, which is higher levels of automation, and that requires significant amount of sensing, and this is where we see opportunities around the road community, and that is the vehicle as a sensor. So automation for the last 10 years has been driver assistance systems, and higher levels of driver assistance have required more sensing, and that sensing is of the surrounding environment predominantly, also to some degree the occupants, so that we can have an exchange between automation and human control. But the environment sensing of the roads, the users and the conditions, they're done from a vehicle point of view to look at the free space on the roads, predict where the vehicle can move to. We see, of course, this might be information which is useful to the roads world, having vehicles which can absorb this data through the sensors and then perhaps pass them on. So to kind of summarize in terms of connectivity, where does it look like? We've got two-way connectivity with OEMs. We've got one-way connectivity to emergency services. We've got two-way connectivity with charging networks, and we've got one-way pulling down information through other routes from the cloud. And if your mobile device is connected, then we have two-way there. But what we don't have at the moment is a passing through of the information that the vehicle can pick up around its environment, passing that on to any of these people that you can see down the right-hand side, any of these stakeholders. So that's really a challenge for the future. And Jed, you're going to pick up from here.
Yeah. If I can have the next slide, please, in a Chris Whitty style. There we go. So thanks, Alan. You know, this is a very short time. I've got 5 or 6 minutes for what is a massive subject. So I just want to explore 2 use cases. One about a measurement around on the roads in the future, and touch very briefly again on EVs. But the issues that we're trying to promote here are things which the country needs to think about, and which you as service providers into the country can contribute to. So first off, as you can see in this picture of a typical expectation of an autonomous vehicle, we are measuring stuff like crazy, and those measurements are comprehensive to compensate for a whole bunch of responsibilities that go with operating an autonomous vehicle. But a couple of questions to think about with this is why are we trying to deliver these autonomous services in the first place? Is it just market driven? Are customers of private owners of vehicles or commercial operators of vehicles just fed up with driving and operating the vehicles for themselves for large proportions of the time, are increasingly tedious tasks? Alternatively, is this a challenge for cities or nation state governments who want to improve the efficiency of the road system in which these vehicles operate? So more coordinated vehicles performing more efficiently with fewer accidents and a higher level of road consumption could be a compelling story. And this subject could be talked about for days on end. But Steve mentioned this in the opening session, that autonomy was a very big theme maybe 2-3 years ago, and enthusiasm for announcing new products and services has dropped considerably. The reasons for that are that it is a lot more complicated than was anticipated. The variability in different marketplaces is enormous, and these kinds of issues turn out to be not something that an OEM of any vehicle type can solve on their own. And one of the key themes that we want to get out of this discussion is to introduce the conversations between the road systems groups and the automotive manufacturers to make this collaborative. So this picture shows all the kinds of measurements that you can take from a very high-end vehicle, which you guys collectively, government, local authorities, could consume to report back and visualize the state and capability of your road markings, the quality of the road, the signage, and indeed the density of consumption and the way the services are being operated. But that has to be done collaboratively, because the volume of information that you want to move around in real time to make that effective is enormous and has got to be organized for success. And it makes there's a whole bunch of technical challenges that go with this. First off is cost. The vehicle on screen at the moment has probably got something around £80,000 worth of sensors visualized here for what could be a premium autonomy level 5 vehicle that can drive itself anywhere on any class of road. The reality of that is it's very unlikely in the private ownership models for those sorts of vehicles to be ubiquitous in the system. So another relationship between OEM and infrastructure type organizations is, can the infrastructure measure the bulk characteristics of the road and provide a quality of data surrounding the road, and then with a much more limited sensors, all vehicles could potentially then interoperate with that class of road moving forward. That in turn then brings up safety and cyber security principles, because dictates could be coming from the infrastructure rather than a property of the OEM itself. And finally, amongst the challenges in the autonomous driving space, I just want also to refer to there is a huge amount of attention being talked about in operating these classes of vehicles in urban areas, but there's very little being thought about in terms of the implications for rural operation, which crosses over neatly into our vehicle. Into electrification of vehicles. The same problem persists there at nation state level for the difference between urban operation and rural operation. The principles of service provision and coordination with the OEMs to manage the problems of urbanization versus rural delivery comes through. And at the moment, the policies are oversimplistic in terms of the implications of the density that EVs will bring to bear in this space, not the least of which is, as Steve mentioned in his opening piece, the charges on the challenges on charging capacity, the ability to supply energy in the peaky formats that are likely to go with a 50% plus of vehicles in a space being electrified. So if I can have the next slide, please. Thanks. So just very briefly, we want to talk about the transformation effect. So we're after COVID, we're very familiar with the principles of waves doing damage and having implications on society, and the automotive sector and mobility sector is very much driven in a similar pattern, and we are just going into our third transformational wave, where the vehicle architectures are going to need to change to allow for these new high performance software driven sets of functionality. There is an opportunity for the UK to set the game in this to play a significant part in that game, or alternatively we're likely to have to react to standards coming out of other major economic systems like the EU, China, the Far East, and indeed the States. So there is an opportunity for us to set that standard, and to take part in that, but it does require organisation, and we are particularly conscious, coming from the ASIN team, that we have organised on the vehicle side, particularly to try and coordinate some of these kinds of things, but on the infrastructure side, we don't have a strong relationship there yet, and we're not conscious that in the infrastructure side there is also a collaboration with these higher order complexity system engineering conversations too. So I'd like to just hand back to Alan to highlight some of the initiatives we've got going on in this.
Thanks, Jed. Thanks. I'm conscious that we're out of time, so I'll just leave this with all of you. These will be available in slides after the conference. There are some projects which ASIN is planning this year on safety, approaches to safety and security, EV charging communications, and design of EV charging networks. So please feel free to get in contact with myself or with Jed if you're interested in partaking. So thank you very much. That's our contact details. We'll welcome any contact on those.